Hello to everyone. My name is Alessandro Petraglia. Do you hear me? Yes. Okay, my name is Alessandro Petraglia. I work at University of Parma, and I'm a botanist. And why I am here? Because Marco told me, why don't you, can you go about carbon fluxes and how can we measure and they are useful, it's useful to measure them and ecosystems. You have a little experience, you can talk about it. Yes, I talked several days to what is the right presentation to do, and I changed the title. So the title is not the one, but Vanessa, I told you a couple of days ago. Um, I will not talk about the best measure of carbon fluxes because it's very technical and it's boring. I will say so many things that you already know, but just to talk about it. It is useful to check for functioning in natural degraded and restored condition. That's the question. Two boring slides about peatlands. Peatlands are a very important ecosystem. They cover only the 3% of the world, and they store up to 1/3 of the world's soil carbon. We say to the students this, we know, or everyone of us know this. So they are very important. Keeping this carbon locked away is absolutely critical to achieving this global climate goals. Okay. But they are also very interesting habitats in terms of biodiversity. Organisms that will live in this habitat have to cope with this specific particular habitats to survive. This requires them to adapt their physiology, anatomy, morphology, life cycle, and behavior. That means that due to the reason, peatlands are home to rare and unique biodiversity and represent also incredible and unique ecosystem diversity in the world. Tell us new things that we don't know. Okay. Oh, I think nothing here. So conserving biodiversity is a priority. But peatlands are also wonderful ecosystems because they are cloudy, wet, rainy, cold. Yes. But it can meet interesting people sometimes if you come with them. And many spiders, many spiders in peatlands, so many spiders and other interesting insects and plants. And insects come visit to you when you work, and other very dangerous animal that we are very happy they are smaller than us. In Europe, we have the 12% of peatlands in the world are in Europe. It is very important or not so much so important? It is important because, going fast, drained peatland in Europe emit about the 5% of total EU emissions. So it's a very important number. And the global greenhouse gases emission from European peatlands amount to 30%. So it's very, very important because degraded peatlands in Europe are the 50% about. So it is important to work on peatlands in Europe. And there are so many projects devoted to this, hundreds of projects, but this one, REWET, is not devoted on peatlands, or there are some open lab in peatlands too, but it's very important because we have to REWET, as Chris and Florian told us today, that it's very important. Nature restoration will give us so many opportunities. And so I thought, why don't put a slide on nature restoration low here, to see the things that I think they are important, and probably you too. I like very much the word binding. Not in general, but in this case, because it says to us that probably, if nothing change, we must do this, and it's very important. Covering forest, grassland, wetland, and peatlands. I searched the word peatlands all across the nature restoration law. I found it several times. And the natural restoration law recognizes that cost-effective adaptation to climate change can be achieved by protecting and restoring wetlands and peatlands. I read this in the books. In ecology, it is 20 years at least we know it. It's very incredible that many people recognize it. And having a great number of biodiversity ecosystems leads to high resilience to climate change. That's very interesting. Oh, I start to read the natural restoration law and I finish, yes, a little tired, but happy. Natural restoration law emphasized the need for rewetting peatlands. I don't remember the article, but I read it. And fine, I finished. Two important words. Florian, look at this in the presentation, and I'm happy. Restoration, the word restoration, it is in the article, in the part named definitions. There is a part named definition with restoration. Means the process of actively or passively assisting the recovery of an ecosystem, blah, blah, blah. Every one of us know what is restoration. And the other word is good condition. Good condition, Chris talked about good condition several times, and I like it. Good condition means something, in general, that is strictly linked with species, vegetation, structure, and, Marco, functions. So we have to improve this habitat and bring back them to good condition, also in structure, function, biodiversity, so we can check for them. Rewetting and restoration of degraded peatlands is urgently needed to meet biodiversity and climate goals. Okay. This is the first time that we talk about this. No, hundreds of projects have been funded by EU in recent years, in the last 20 years. LIFE project, for example, devoted to restore different kind of wetland ecosystems. And the one for REWET, for example. But we need more REWET-like projects aimed at restoring peatlands to good conditions. And it's very easy to find them, because in Europe we have more than 40% of drained peatlands. So we have a lot of space where we can work. Okay, first of all, find a good place to work. It's very easy to find. Chris showed that, for example, in Flanders, you can go everywhere. And yes, here, and here. In Italy, there is something that we know that we can work on. We need to find a way to rewet these peatlands, but it's not like to take a glass of water. We have to work into project and to see what we have to do. And we must implement a monitoring protocol. That's very easy when you think about this, but not so easy in general, because we have to check that our activities have returned the peatlands back to good condition in terms of structure and composition of the vegetation and in terms of functioning. How can we check that rewetting has brought peatland back to good conditions? Check for good condition in the short time, usually allow the national and European project, because we have to verify it in 2, 3, 4 years. We don't have 10 years or 20 years to see, oh yes, okay, it works. But we know that in a couple of years, it doesn't work. Peatlands from the space, from an airplane, from a rock, they're from very close. Regular patterns and peatlands, many of us know that these beautiful patterns. Peatland develops surface pattern regularly ordered vegetation types that are not classification constructs, but are real discrete entities controlled by different ecological drivers, such as, for example, one of them is water table depth. And many of us studied this in very interesting and classic scheme of more than 70 years ago. Okay, so vegetation is strictly controlled by ecological drivers. Everyone knows it. And water table is very important in this. It's the most important one. If you drain a peatland, the water table changed the water table depth, and vegetation changed, with many species coming into the ecosystem, many that are species that are plant species, for example, that thrive in drier habitat, in more mesic habitats. So for a botanist, for a plant ecologist, it's not difficult to see how far is a peatland from good conditions. It's very easy to go and see, oh, okay, no, it doesn't work. And so, okay, I finished the presentation. Because just as plants can tell us how far we are from good condition, plants can tell us if our rewetting project has worked. No, of course it's not, because it takes several years for plants to come back. And even if they are locally available, the recovery of typical vegetation structure of the typical species composition may be very slow. So in a couple of years, it doesn't work. Even more so, if the rewetting action is aimed at raising the water table in a disturbed agricultural area where we have not at all the species and the vegetation that should be there, or in a very old peatlands that has completely changed its function, and so vegetation is not the one that we expect to find. Or probably the rewetting intervention could aim only to reduce carbon loss and not to restore vegetation. It's possible, for example, if we would like to talk about polycultures, I want to talk about that. So we don't want to restore biodiversity, but we want to use that. So we cannot check for biodiversity in these habitats. Therefore, the study of vegetation can indicate its state of conservation and the need for rewetting, but it may not have the power to confirm the success of rewetting if we have only 1 or 2 or 3 years after the rewetting, or if we have no intention at all of restoring at all the biodiversity of the habitat. I'm not saying that it's not useful, but in some cases, we have to use another method or combine this vegetation surveys with other proxy of good condition. Are there any indicators of good functioning of this ecosystem? Yes, they are. Many of us know this, and I go quickly. Oh, okay, I wrote this. It's not a beautiful drawing. It's just to say that any one of us that carbon fluxes in peatlands in good conditions are mainly controlled by the depth of the water table. Don't look at the arrow. Okay, you should look at the arrows. I should say look at the arrows, but don't look at the arrows because they are not very precise. Okay, you know. But the protagonist, the character of this presentation is ecosystem respiration and water table. So temperature. Oh, this is better. Water table is the first one, but temperature and soil moisture are very important. Have a look, for example, to the third one, close to my students that are measuring it. Ecosystem respiration do not increase if soil moisture, with temperature, if soil moisture is 100%. Okay, we know that water table control it, but if you have 5 degrees or 50 or 25 degrees, you have no more ecosystem respiration. No, it doesn't increase. If you have the water table very close, but very close, it's very important to understand what's the meaning. But if soil moisture drop down, when water table drop down, temperature drive ecosystem restoration. That is almost the end of what I say, and you are thinking that I'm finishing. Is okay? Yes, it is. Because we can check for ecosystem respiration to understand if our rewetting works. 1, 2, and have a look to soil moisture 26%. Temperature works very well. But there is another important thing in some kind of wetlands it's not so important, but in peatlands, yes, that is vegetation. You see different patterns of ecosystem respiration in water table depth against ecosystem respiration, and you see the different kind of vegetation types drives in different ways the ecosystem respiration. So it's very important to know that. Okay. As ecosystem respiration is closely linked to water table depth, is our rewetting action has restored water table depth close to the ground level, we are very likely to measure lower ecosystem respiration than before rewetting. It's very easy, and it works, and it is. Measuring ecosystem respiration at different points in the peatlands, after we can talk about what I mean. Before and after rewetting is one of the most effective, also in terms of cost, ways of monitoring the success of rewetting on carbon emission in the short term. Yes, of course. We have to measure also gross ecosystem productivity. You have to measure net ecosystem exchange. Okay, if you can, you should, and you will understand so many interesting things about the recovery of ecosystem function in your study area. You can do it in this way, with collars, with different colors also, with unconventional collars, with a cubic chamber. Or you can use artificial light too if you want to simulate different light, and because for plants that is important. Or no light at all, like system respiration or soil respiration, removing vegetation also. Or you can do it at night if you need. It's very simple, but we need to be clear about what is meant by in close contact, close to the ground level, close to the surface, and take it to decrease again for half rewetting. I like very much. Water level management plays a critical role for mitigation purposes with recommended optimum range of 0 to 0.2. I found it somewhere. Yes, I agree. What could happen if we do not this? I can show some measure of soil respiration in Italy in a very badly drained peatland. Water table, we measure water table at 86.5 times during the growing season, and the water table depth was on average 40 centimeters. Okay. Do you have an hypothesis? I know you have. I know you have. What happened? But I asked to my students, and my student says, oh, I have an hypothesis. He was excited about that, to have an hypothesis. I'm sure that it doesn't work, as you told us. Because if you the water level is 40 centimeters down, it should emit carbon. And probably ecosystem respiration is driven by temperature and not by water table. Yes, I said, great, it works. Water table, WT, has a role. Of course, if you take the full year, no, okay, we talked about that. It's not so important. Every one of you know. The main driver of soil respiration is not the depth of the water table, but it's that this means that these peatlands are not in good condition in terms of their functioning as carbon sinks. The hypothesis of my master students was correct. If the depth of the water table is close, but not very close, the peatland will continue to lose carbon from the peat. When we say to someone, bring back the water table close to the ground surface. For an agriculture, close can be half a meter. Too close for agriculture. And someone could ask, okay, don't rewet up to the ground level, but bring back the water table to 30 centimeters. It doesn't work. It's bad. And I'll show you why. In this drained peatlands, no, every one of you know why. Knows. Soil respiration is primarily controlled by soil temperature and moisture, with an interesting and destructing role of their interaction. First of all, you see the three lines, they increase with temperature. Soil respiration increases with temperature. This is not surprising because the depth of the water table is far from the surface, and this means no saturation at all. But what is very interesting, in my opinion, look at the red arrow and at the blue one. Where the soil is drier, respiration increases less with temperature than where the soil is wetter. So wetter soil emits much more carbon than drier soil. It's not surprising, I know, but it's a bad thing because we continue to rewet and redry, re-wet and redry, we accelerate the process of emission. So we have to do very big, very important, very strong intervention and control for that. If the soil is wet but not saturated, the temperature will do its work, stimulating carbon loss from these important ecosystems. So, I don't know how many minutes I have, but I'm finishing. No, okay, sorry. A short protocol. It's very useful to study vegetation in the area where you want to raise the water table. The vegetation will help us to identify the points where we need to carry out monitoring, for example. It's an important help. Or we can do it in several ways, with drones, with satellites, okay, too. But it's costly. If the peatland is severely disturbed, we have to give up the help of vegetation and use other methods to locate monitoring plots. It's second one. Now it's time to increase the depth of the water table. Very close. What's the meaning? We talked about that. Very close is zero. You have to see the water. Make sure that you cover as much of the area as possible with this average groundwater depth, and pay attention because peatlands are sometimes are very large areas that with a very different, very slightly different, frequently slightly different. How can I say? Everyone of you knows peatland, and you know what I'm saying. Micromorphological areas, and it's difficult to control for water level. Set up a series of ecosystem respiration measurements and other measurements, which should be lower than before wetting, even in the first year after the intervention. I hope it should. If the ecosystem respiration values are lower, your rewetting has been successful. We can talk about primary productivity, we can talk about gross ecosystem productivity, okay, but ecosystem restoration should work. Do not forget to study vegetation if it's the case, and be patient, because rewetting has been shown to take several years to be fully successful. You should not expect to obtain the result you want after 1 or 2 or 3 years. There are some papers that show that after 12, after 15 or 17 years, net ecosystem exchange has not come back to the beginning, if we know it, the beginning. But the success of the intervention is if we lose less carbon from soil. And personally, I would add that, however, that we already know this. How can we do? We know what we can do, and we must do now, as soon as possible, please. If we leave this wonderful ecosystem in bad condition, they will lose their carbon stocks and their wonderful biodiversity forever. And thank you to everyone.
Thank you so much, Alessandro.
No, thank you.
So sorry that I have to ask you questions and say thank you to you with this, because I don't know what I did with my microphone, the microphone that I have in my hands.
No, sorry.
If you see the microphone in any place, please tell me, because I don't know what I did with that. Thank you very much for your presentation. We don't have questions in the chat. I don't know if people present here have questions. Frank, I know that you had questions because of the respirations and the modeling that we are doing. Actually, I wanted to ask some questions as well.
Thank you so much for your presentation, Alessandro.
Thank you.
I was very focused in your presentation because I'm trying to model the carbon fluxes from the ecosystem to the atmosphere, or is exactly. So you are mentioning constantly carbon. I want to ask if you are referring to carbon dioxide or methane,
yes,
or both.
No, I am referring to carbon dioxide.
Exactly.
That's perfect. You're right. You're completely right.
Okay. Now,
because in the graph were clear, but I wrote greenhouse gases, and the original title had to do with methane, but I was focused on CO2 fluxes.
okay, thank you.
Because I'm old.
No, it's because I understand better the carbon dioxide cycle, because I'm very familiar with the concepts of respiration and gross primary productivity.
Yes,
but
I know.
have
I know.
some
Sorry, so many of you are very familiar with
No, I don't know, but me, yes. And that's all because I'm struggling trying to understand the methane cycle sometimes.
this. Yeah, me too.
Yeah.
Thank you, Ram, for your question. Regarding this as well, and also you mentioning, Alessandro, that so the monitoring is necessary. Also, we have already listened to Chris and also Florian talking about the nature restoration law that is enhancing and encouraging people and member states to monitorize ecosystems and also the REWET and so on. How do you foresee the technology? Because also, I mean, there are many people doing the monitoring, and also we are in REWET, we are trusting in the chambers, in the collars, and also in the eddy covariance towers, we are really nice. But also, do you foresee the path in the short, medium, or long term to have like a guideline, like something, a proxy, something that we can put as a stationary thing in our wetlands, in our nature, that gives us constant information, real-time information? Because I think we have many representatives here as well. Even we are working towards artificial intelligence to be applied on these cases. Also here we have Bernard that works for RSS, that is experts in satellite imagery, drones, all these things. I think we have the capacities and the capabilities to
yes, you have.
this.
Yeah.
But I don't know if you see that this is going to take a long time.
Okay, thank you for the question, but it's a very difficult question. And I will answer starting from my presentation that is clearly and not, it's not the case that is very old-fashioned. I talk about vegetation more only with the eyes and with static chambers. But there are so many things that that every one of us can do that are better than this. However, satellites, drones, artificial intelligence, it's very, I'm scared about that. It's very interesting, and they can be very useful. For example, with many things that are very eddy covariance. I didn't talk about eddy covariance methods. Okay, you can do it, and you're doing it. It's very important. But there are also automatic chambers and no static chambers, so you can monitor different part of the. But Chris and Florian told us about several billion euros in this project. It's probably many people should work on this. Many people that could REWET areas without doing this high technological work. It's not my opinion, it's just a point. This should not, if they cannot use artificial intelligence, if they should not use, they have the eddy covariance tower everywhere, because they are very, you need money to buy them. Okay, but you can do a rewetting. You can do, for example, 1,000 hectares in that area, monitoring for the effect only with a static chamber, and you can do it because you say, I invest the money I have to rewet the area, and I assured and I say to scientists and the European community that it works because I measured the ecosystem respiration. So this is another different point. So the best is the road you suggested. It's not my guideline, but your guideline.
I know.
Okay, but I think that it's not useful to understand that you can monitor also with plants or ecosystem respiration, ecosystem functioning, because in some places, where you cannot restore biodiversity because you have it's mandatory to maintain agriculture, you should not rely on plants, you should not rely on birds, on butterflies, but you should rely on ecosystem respiration, for example. That is very easy to measure and not at all expensive. You understand my point?
I understand totally
Thank
your
you.
point. Sorry for asking some
No,
very
no, no,
difficult
no, no.
question.
Thank you very much for your question.
Just
Okay.
also try to encourage for a debate, because also, I don't know, from my point of view, and I'm an expert on monitoring and looking at the state of the wetting of our ecosystems. But I think that the nature restoration law is making a point on also facilitating as much as possible such a necessary task, which is monitoring. And I think that as soon as we provide, we as a researchers and working towards this task, as we provide a very easy to use, but something that is feasible and that has potential to be applied, and I think it can be a tool to be taking advantage from the member states and accomplish this task of the nature restoration. But I just wanted to ask you for being an expert in ecosystem restoration. Thank you very much.
Oh, thank you.
Any question from the people here present? Can we go to the next presentation? Thank you very much, Alessandro.
Thank you very much.